We are going to begin predicting formulas of ionic compounds. Make sure you have that ion list out to help you. When you're working with an ionic compound, it's going to consist of a cation and an anion. Remember, your cations have a positive charge. Typically, they're going to be metals. Not always. You do have that polyatomic ion NH4 plus 1. That is made up of two nonmetals, but they act like a cation, a metal, a positive charge. Anions are your ions that have a negative charge, and they are your nonmetals, and this is where you're typically going to see most of your polymers. Ionic compounds are composed of a cation plus an anion, and it's going to be in a fixed ratio, and you want these charges to cancel out. You want them to be neutral. So when you're combining your magnesium cation with your fluoride anion, we want these charges to equal out to 0 when you add them up. So if Mg has a +2 charge and F has a -1 charge, will the charges cancel out to 0? They will not. To get them to cancel out to 0, you need to have 2 of the fluoride. That's where you get the formula MgF2, because you need 2 of the fluoride to cancel out 1 of the charge of the magnesium. So these are your rules for writing your binary ionic compounds. The first rule is the positive ion will be wrote first, then the negative ion will be wrote second. So we have ammonium and we have dichromate. We're going to use a method what we call cross and drop. What that means is your numerical charge is going to cross over to the other ion, and what you're dropping will be your charges. You won't write the charges. So you end up with 2 ammonium that have a charge of 1, and this is understood to be 1 of your dichromate, Cr2O7, and that would cause your charges to balance out or equal out. These are polyatomic ions. These are a group of atoms that act like group of atoms that act like a single atom, and they have a charge. So they're basically molecules that have charges. So here's another one where we have aluminum that has a charge of 3, sulfate, SO4, that has a charge of -2. So the 2 is going to cross over here to the aluminum. The 3 is going to cross over here to sulfate. So if you multiply 2 times 3, that's a +6. And a 3 times the -2, it's a -6. So that equals out to 0. Here we're going to put together calcium chromate. So they both have a charge of 2. So when we cross and drop them together, we get Ca2 parentheses CrO4 parentheses 2. It's so important around your polys that if you have more than one, you have to put the parentheses around them. If not, you end up with the formula CrO42, and that does not look right at all. Remember when we worked with empirical and molecular worksheet and we could reduce these 2? That's what we're going to do. With ionic formulas, we want them to be reduced to the empirical formula. So we end up with the ending formula of CaCrO4. The cross and drop works most of the time, except when you have to reduce, because if you look here, we already see that a +2 and a -2 equals out to 0, so we just need 1 of each of those ions. If we look at lead-4 carbonate, The 4 is going to cross over here to the CO3. Notice we put parentheses around the CO3. The 2 is going to come over here to the PB, and we can reduce the 2 and the 4 by 2 to the PB parentheses CO3 parentheses 2. That's lead 4 carbonate. Again, it's only ionic compounds that we write the empirical formulas. What is a covalent or a polyatomic ion? So basically, a polyatomic ion will be atoms that are covalently bonded together, but they're going to gain or lose electrons, which means they acquire this charge of -1, +1, negative, so on. So poly means many, so you have more than one atom, and they're acting like a single atom. This is a strong bond, and out of this right here, it's always OH that students forget, polyatomic. So I'll see a lot of this when they write a formula, and they basically wrote water backwards. So don't be that student whenever you take your quiz or your test and you forget to put parentheses around the OH, because we need 2 of the O and the H, not 1 oxygen and 2 hydrogen. And when you get your quiz back, you go, oh, but it is the one that is forgotten the most. So you're going to first start with being given the symbols to cross and drop, and then you're going to work up on your homework where you're using your ion list to write the symbols and then cross and drop to get the charges. So for instance, in our first formula here, we have lithium chloride. So go to your ion list and write the symbol and the charge. And then you're going to cross and drop. So that means you're going to end up with the formula of LiCl. If you look at our next formula here, we have sodium hypochlorite. So sodium's formula is Na, and it has a charge of +1. I apologize, I'm using my mouse. I cannot write on the computer screen. Hypochlorite, this polyatomic ion you need to flip over, and you're going to see what's called the periodic chart, not table, chart of ions. And notice in the center, in the top center, you're going to see a rectangle and a list of some polyatomic ions. In that list, you should find hypochlorite. So its symbol is ClO negative. So again, what's going to happen, and that's an A there, is you're going to cross and drop and you're going to write your formula Na and then ClO. Typically, with this being a poly, we don't put parentheses around it. But if you want to put parentheses around it until you get familiar with your polys, I kind of think of them as hugs. They're holding the atoms together. You're more than welcome to do that. Here we have iron 3 carbonate. It has a charge of 3. Carbonate is CO3, and that's a -2. So when I say cross and drop, you have Fe and then CO3. This 2 is going to cross over here, the Fe. We're going to put parentheses around the CO3 and the 3 that's right here is going to cross over, and the 3 is going to go outside of the parentheses. So you end up with the formula Fe little 2 parentheses CO little 3 parentheses little 3. Again, you have to have the parentheses. Actually, if you don't, it looks like CO33. And again, what are we dropping, or what are we not writing? We're not writing the positive and the negative because we're compound is neutral. Here we have barium sulfide. So we have Ba that has a +2 charge, and sulfide that has a -2. So when you go to write your formula, you have Ba and S. This 2 is going to cross over here to this S. And this one is going to cross over here to the Ba. And remember, with this formula, we can reduce these by 2. So our formula will actually end up being BAS. And finally, we have the formula copper 2, not copper 1, so it has a charge of +2. So make sure you know which metals have Roman numerals, which ones do not. And then we have oxalate, and that is C2O4. And it has a charge of a -2. So when you write the formula for this one, this 2 is going to cross over and go here. We have to put the parentheses around our polyatomic ion. Can't touch it. I know. NC hammer. You're going to hear me say that a lot. Can't touch it. Okay, and that 2 is going to move right over here. Now, what can we do? We have to reduce this down. Can we touch what's inside of the parentheses here and reduce? No, we can't. So we can reduce the 2 outside of the parentheses to get the formula Cu. If you want to put the C's around your poly, you can. 2O4 and then parentheses. Technically, we do not need them, so you would not write them or you would not see them. If you have questions, I will be more than happy to help you out. Good luck on your assignment. Use that